The creation of Earth is a process that scientists believe took place over billions of years. Here's a detailed explanation based on our current understanding from the field of planetary science and astrophysics. Earth's creation begins with the formation of the solar system. This process likely started from a giant cloud of gas and dust known as the solar nebula. About 4.6 billion years ago, this nebula began to collapse under its own gravity, probably triggered by a nearby supernova explosion. As it collapsed, it spun faster and flattened into a disk, with most of the material gathering in the center to form the Sun. The rest of the material, composed of dust and gas, began to clump together through a process called accretion. This was the beginning of planet formation. As the solar nebula continued to cool, small particles of rock and ice began to stick together, forming larger and larger bodies known as planetesimals. These planetesimals collided and merged over millions of years, gradually building up larger bodies. In the inner part of the solar system, where it was too hot for gases to condense, these planetesimals were mostly made of metal and rock. The growing planetesimals in this region eventually collided and merged to form the Proto-Earth, a young molten planet. These collisions also released huge amounts of energy, causing the planet to heat up and partially melt. Formation of the Earth's layers. As Proto-Earth continued to grow, heavier elements like iron and nickel sank toward the center due to gravitational differentiation, while lighter elements like silicates floated toward the surface. This process created Earth's layered structure. The core, made up primarily of iron and nickel. The mantle, made up of silicate rocks rich in magnesium and iron. The crust, a thin outer layer of lighter silicate materials. The Earth at this stage was still molten, but over time it began to cool and solidify. The outer layer formed a solid crust, but the interior remained hot, and volcanic activity continued to release gases like water vapor, carbon dioxide, and nitrogen into the atmosphere. The Moon's formation, around 4.5 billion years ago. One of the most significant events in Earth's early history was the giant impact hypothesis, which suggests that a Mars-sized body, often referred to as Theia, collided with the early Earth. This collision was so violent that it caused a significant portion of Earth's outer layers to be ejected into space. The debris from this impact eventually coalesced and formed the Moon. This impact also had major implications for Earth's tilt, rotation, and the development of the atmosphere and oceans. The Earth's axial tilt, which is responsible for our seasons, was likely influenced by this collision. As the planet cooled further, the atmosphere began to evolve. Initially, the atmosphere was mostly made up of hydrogen and helium, but it was soon replaced by gases released by volcanic eruptions, such as carbon dioxide, water vapor, and nitrogen. Over time, water vapor condensed into liquid form, forming the oceans. The early atmosphere was likely very different from today, with no oxygen and high levels of carbon dioxide. It wasn't until later, with the rise of photosynthetic organisms like cyanobacteria, that oxygen started accumulating in the atmosphere, leading to the Great Oxygenation event, around 2.4 billion years ago. The Earth, with its oceans, atmosphere, and energy sources, eventually became a suitable environment for life to emerge. The exact process of the origin of life is still a topic of research, but it is generally believed that life began in the oceans, likely in the form of simple, single-celled organisms around 3.8 billion years ago. The development of life on Earth gradually transformed the planet, creating a dynamic system where biological processes interacted with geological processes. This led to the creation of the atmosphere we have today, with the production of oxygen by plants and algae and the carbon cycle that regulates Earth's climate. As Earth continued to evolve, the solid crust began to break into large pieces known as tectonic plates. These plates float on the semi-fluid layer of the mantle and move over time, leading to the process known as plate tectonics. Plate tectonics is responsible for the formation of continents, mountains, earthquakes, and volcanic activity. This dynamic nature of Earth's surface has shaped the planet's geology, creating the continents and the oceans we recognize today. The Earth's surface is continually reshaped by the movement of these tectonic plates. The Earth formed through a combination of cosmic events, such as the collapse of a solar nebula and the collision with Theia, along with geological and biological processes that have shaped its surface, atmosphere, and life forms over billions of years. From a molten mass of rock and gas, it gradually became the habitable planet we live on today, capable of supporting life due to the complex interplay of its environment and living organisms.